these are the mandates for the apportionment of seats in the U.S. House of Representatives. So the apportionment is based on the census per the Constitution, also that the census occurs every 10 years. There has to be at least one representative per each state, also per the Constitution. There are exactly 435 seats in the House of Representatives according to the Apportionment Acts of 1911 and 1929. And then since 1941, the method used is the method of equal proportions, or Huntington Hill. And these are the websites that this can be looked up. Notice that I use government websites, so archives.gov for the census here. Then at least one per state, again, the Constitution. Exactly 435 seats, house.gov. And method of equal proportions, I found it at census.gov. And of course you can check those out at many other online sources. This is a website at libertext.org for a math book that covers apportionment. And this is a description of how the Huntington Hill method works, what's called the method of equal proportions. So the Huntington Hill method attempts to minimize the percent differences of how many people each representative will represent. And I will try to show that in my Excel sheet for the couple of examples that I have planned. I'm going to go through these 4 steps here. So I will show the standard divisor, which actually I will call quite often the modified and adjusted divisor. Just before it becomes modified or adjusted, it will be the standard. About the standard quota, then the geometric mean, which as you see is the square root of n times n plus 1, n being perhaps the number of seats in the House of Representatives, so it's an integer number, times another integer number, so 1 up, take the square root, I will also show that. And then the initial allocation of the seats, and I will just call these seats. Then there's a 5th step. The 5th step is a correction step, where it says change that divisor, that standard divisor here, change it to recalculate the quota and the allocation, because the Huntington Hill method actually might give a number that is larger than the 435 or smaller than 435, and it needs to be adjusted. And again, you will see this one here as well, how that is being done. So here's the first example for 1950. And for that I need the original data, and I got this big Excel sheet from the census website. So I'm gonna copy the population per state and the number of representatives. Notice that the total comes out to 435. So we already know what the results are, and then I'm going to show how they actually compute it, and that indeed they were computed correctly according to the Huntington Hill method. I'm going to take out here Alaska and Hawaii. There we go. They weren't part of the United States at that point. They were still territories. So I'm going to I've copied now the population here at the time for a total of just 149 million. These days, 70 years later, it's more than 300 million. And the seats, as I said, we already know what the results are. And on the very right-hand side, this side here, this is where we're going to calculate that indeed these are the seats that everyone gets, according to the 4 steps plus the correction step. This one here was also given on the census website. However, I'm going to have the spreadsheet calculate these here. So this is the number of people living in the state per one representative. And we can see if we look at the last ones, yeah, they're all different. because we have to have integer numbers for seats, and it's not just one certain amount of people living there per one representative, but they're different from one state to the other. Overall, we have apparently an average of 344,587 back then in 1950 per one representative. That's the total population divided by the number of seats, the 435, which then gives this one number here, 344 million. That is the standard divisor. I already called it the adjusted or modified divisor because at the end it will be actually different. Notice that this one is also being added here, the correction term, which will be step 5, which I have included right here. At this point, it's 0. We're just going to use, for now, the standard divisor, and then we'll see. All right, again, I don't need Alaska and Hawaii. All right, now the math begins. This one here is divide the population by the standard divisor, so the 344 million, there it is, yeah, which comes out to 8.89. That's what it says here. Right. The next one is you take this number and you round it down, so 8.89 becomes 8, and here you round it up, so 8.89 becomes 9. So these are these two numbers, you can see it here, round up and round down. This one is the geometric mean. That's the formula that you saw earlier. So this one is take the lower quota, 8, multiply by the upper quota, which is 8 plus 1, so 9. 8 times 9, and then take the square root of that. So 8 times 9 is 72. Take the square root of 72, apparently comes out to 8.49. And then, well, I talked about how we compute the seats in a moment. I'm going to pull these 4 down here, just for the first few states, perhaps past Hawaii. There we go. And again, I don't need Hawaii. I don't need Alaska. All right. Now here's what happens with the seats. If the standard quota is larger than the geometric mean, take the upper quota, so 9. If the standard quota is smaller than the geometric mean, well, take the lower quota, so 2. And so on for all of these. Pull this down. Conveniently, Alaska and Hawaii are not included in this case. And you can see that's what happens. Yeah, so the 8.89 here then becomes a 9. The 2.18 becomes a 2. 5.54 is larger, so it becomes a 6. The 30.72 is larger, so it becomes a 31, and so on. Right. Gonna pull this all the way down here to Wyoming. And then we can see an interesting side effect. One of the legal requirements is that no matter the population of the state, it has to have at least one representative. And Wyoming has such a small population that, well, the way it's calculated, this one here, 0.84, larger than this one, 0 here, which is, round down 0, round up 1. 0 times 1 is 0. Take the square root of 0, still 0. And so this one here. So this one is larger than this one here. And the legal mandate is there. Wyoming definitely gets the 1 seat. The same thing, by the way, happens to Nevada here. And the same thing happens, I believe, to Delaware. All right, I'm going to pull this one down here. The persons per representatives. And take these 2 out. Now what I just said about Nevada is a very good example here, because it had such a small population back in 1950. Apparently Las Vegas was a really small town at the time. So it has such a small population that we can see here, compared to all the other states, Nevada has such a small population that, wow, it should have like twice the population in order to get at least one representative. But it doesn't have to. 160,000 is just fine. In fact, even if it had just 500 people living in the state of Nevada, it would have still gotten the one seat here, due to the calculation of the Huntington Hill method and due to, of course, the constitutional mandate. So again, that's a nice side effect of that. All right, let's see what happens with the seats. So these are the seats computed. Again, we already know what they should be, but these numbers over here are actually based on the computations. So they ought to match up. Well, let's go down and notice that Huntington Hill method, using already the first 4 steps, they're already done, actually allocated 439 seats, 4 too many. This is where the 5th step comes in that says, well, you gotta adjust the standard divisor and make it an adjusted or modified divisor by adding or subtracting a correction term. When this one is larger here, 439, than the 435, we will add a correction term in the neighborhood of a few hundred or a few thousand that we're going to plug in here, depending on how much we actually need. And that then will correct this number here. All right, let's go on here. This last one here is divide the standard quota by the geometric mean, so this kind of ratio here. And I'm going to pull that down. I found at least one source where they're doing something or mentioning this one here. This one will become very handy for these purposes on how to do the correction. Let's look at these numbers here. The persons per representatives. Again, actually, these numbers here ought to be the same as these numbers. However, due to us having 4 more seats, actually 4 of these, of this entire row here, are going to be off. And we have to identify which ones. Well, these numbers here, persons per representative in each state, ought to be relatively close to each other. And we can see that they're in the 300,000s, with a little bit of an outlier here, Idaho, 294,000. But of course, they're not the same. So some are larger, some are smaller, and that, you have to divide the total population by an integer number of seats. So hence, they cannot be the same. Now, back in the method where I explained from this math book, from LibreText, how that is being used, they mentioned something about keeping the percent difference between these numbers to be the smallest. And that's where these numbers come in. That is kind of the difference. Notice apparently here 4% larger, 1% larger, 11% larger. So trying to keep them as small as possible. Another way of expressing these here could be also that, we want to squeeze them together. So we want to get rid of the lower ones or the larger ones, depending. Okay, the way this is going to happen now is that we're going to look at this ratio here, and we apparently have to identify 4 of these that are very close to 1.00. And once I've found them, I will point out what's going to happen to them. So let's look. 1.0074. That is a candidate for being close to 1.00. Here's another one, 1.0071. Here's another one, 1.009. Let's see, 1.00969. Okay, so let's choose Tennessee here. Color code that. There we go. Ooh, there's one here, Oklahoma. Really, really close. So, color code that one, which means we actually don't need Massachusetts, because that's actually the 5th smallest one. So I still need California here to color code. And I need, which one was it? This one here, Kentucky. Color code. Those are the 4. In fact, if I compare these here, 31 and 30, yes, I actually have one too many. I'm going to pull this one down here and we can see that I chose the 4 correct ones, because each one of these actually say you have to reduce it by 1. Again, we already know the results over here. These are the computations. These need to be adjusted to get rid of this one here and to kick the 7 down to 6 for Oklahoma, for example. All right, let me try to explain these numbers here. Let's go this far, about approximately. Let's look at these here. Notice that Oklahoma has virtually the smallest number among these here. So it has the least amount of people living there per 1 representative. We have to get rid of 4 of these here from the 439, and we have to take it away from a state that allocates just too many representatives to a population that is just too small. So in this case, 319,000 per Oklahoma. Yes, when we adjust it, actually Oklahoma will get quite a bit larger. But, well, that's just the nature of the beast. And unfortunately, Oklahoma loses out, but that's the way it is. Notice, by the way, that North Dakota is actually smaller. But North Dakota only has 2. Now, if we gave just 1 here to North Dakota, right there, if we took 1 away from North Dakota, here's what would happen. They would have 1 representative for all the 619,000 that would be living there, and that really would be unfair to the North Dakotans. So let's see what happens with Oklahoma when we do that. And it doesn't take much because this number is really close to 1.00. I did that ahead of time, and it actually just takes a term to correct. I mentioned hundreds and thousands earlier. In this case, because it's so close, it only takes 30. And there it is. Putting the 30 in here, which is being added to what used to be the standard divisor, 30 added now, reduced this number here from 439 to 438, and indeed, Oklahoma got rid of that -1 here, so the 6 here matches this. Again, we already know the results. In the meantime, the number per population here, that matches now this number, of course, went quite a bit larger. In fact, it's the largest one in here, except for the 395,000 for Rhode Island. So, well, still, there's nothing we can do about it. We're trying to be as fair as possible for the apportionment. Okay, not we, but the mandate to figure out the fairness of apportionment tries to be fair to all of them. And yeah, unfortunately, Oklahoma now has a relatively large number of people per 1 representative. And that goes back to, let me see if I can find this one here. It's just one here where it says attempts to minimize the percent difference for how many people each representative will represent. Minimize the percent differences between the states. So the number of people per representative. All right. By the way, I forgot to mention earlier, I noticed that a number of these states are actually missing these numbers. These numbers are already below 1.00, so they're 0.99 or 0.97 or 0.91, something like that. They already have the maximum number of seats. They cannot be reduced anymore because these numbers actually would get larger. And you kind of see this here, all these gaps that are here. For Oklahoma, there is no number here anymore either because we already adjusted it. Notice that these are actually on the larger side, these 345, 380,000, 395,000. So there's really no point of trying to even adjust them. All right, let's find the other 3. Already marked them. And when I put in my next correction term, so I'm going to change the 30 to 2,400, we will see that one of these 3 -1s will go away. Let's see. Oh, it was indeed Tennessee. So this one here jumped quite a bit. That used to be, let's see, 329. Again, relatively small compared to the others. Yes, again, there's an outlier here, 326,000. Well, but that's South Dakota, which only has 2 to begin with. So we really cannot take one away from them. So it is Tennessee reducing from 10 to 9. As I said, 2,400 is that number. And then I'm going to go to 2,470. that will get rid, let's see, of one of these here. And that was apparently Kentucky, reduced from 9 to 8. And last, it's going to be California. That's going to reduce, so this one is relatively small compared to the others. Well, there's some exceptions here, of course. Delaware and Arkansas actually has a relatively small number too, but this is where the geometric mean comes in. Notice that Arkansas has slightly larger here, and California has virtually the same, so it is closer. So if we took one away from Arkansas, it would be too unfair to Arkansas as compared to California, which has 31 seats to begin with, or 30 actually, once we fix it. All right, so I'm going to change this divisor one last time to 2,550, because I already knew these. There we go. And this one is gone, and all these others here are gone because, yeah, it's all adjusted, and here is indeed California's 30 seats. Again, we already knew the results, and this is how the seats are computed. It's actually mathematically not too hard. Basically determine the geometric mean, which is straightforward, it's the square root of two integer numbers multiplied, and then adjust the standard divisor by adding or subtracting a correction term. All right, let's go to the other example, so 2020. Again, I'm going to copy from this sheet here, the 2020 census data, with, again, the results. Oops, I have to start Alabama. There we go. And there we go. I'm going to pull this one down again. I have the spreadsheet calculate the average people per one representative. So 70 years later, the population of the United States has more than doubled. Let's see if that's true, more than doubled. Yeah, more than doubled, 149 million compared to 331 million now, which means these numbers are much larger. Instead of 300,000, these are in the 700,000, and so on. This is our standard divisor, which soon will become, again, the adjusted or modified divisor, and we need 435 seats. Again, this is the same as before, standard quota, lower one, so round down, round up, 6 and 7, 6 times 7 is 42, take the square root of 42, must be between 6 and 7, or it's 6.48, and then since this one is larger than that, this one here takes the upper quota of 7. So again, I'm going to pull these four down, like here, perhaps down to Illinois. This time, of course, I do have Alaska and Hawaii in here. I'm going to take the seats down here. There we go. And again, even though Alaska has a relatively small population per constitution, they still will get one representative in the House, no matter how small their population is. By the way, I do live in Alaska. I'm going to pull these all down. And come up with 437, which are too many. Okay, I'm going to pull this one down. There we go. Again, these numbers here ought to match these numbers here. But because we have the 437, yeah, two of these numbers are off. Same thing with here, the number of seats here that is being computed to the number of seats that it will be. Again, we do know the results already. Again, two of these numbers are off, somewhere among these 50 states. Again, take the ratio between the standard quota and the geometric mean. There we go. And find the two numbers that are closest to 1.00 right above it. By the way, if these number here would be smaller than the 435, we would have 0.99, 0.97 all over the place instead, and then we would have to look again which one is the closest to 1.00, so we'd be looking for 0.999, that kind of thing. In any case, just as the example before here, there's a candidate right here, that's New York here, 1.0024. There we go. I'm going to highlight that. And Minnesota, actually the same one, 1.0024. That was a surprise to me because I already looked at these data. And there was a third candidate. Ooh, Ohio is closer. All right. Now we actually have 3. Let me see if there's anyone closer. And if you look carefully, no, there's not. There's a 1.0097, but that's larger. So we have 3 candidates, but we only need 2. So, that's kind of a conundrum. Well, let's look at these 2 numbers here and extend actually the decimals. A couple more. And here a couple more. And we can see that New York is just a little bit closer. So it will be New York where we have to take a seat away instead of Minnesota. So I'm going to give Minnesota a different color here. Let's see. Like still a reddish color here, but it's going to be New York and Ohio. In fact, when I pull this number down, we will see a couple of negative ones, one for Ohio and one for New York, and not for Minnesota, because New York is actually a little bit closer to the 1.00. So again, we're going to adjust, and you can try any number you want there. Again, usually they're in the hundreds or thousands. I already know what I'm looking for, so I know that in order to increase this number by 1050, I will have it fixed for, oops, didn't mean to do that. I'm going to start over again. When I type in 1050 here, I will have it fixed for Ohio. And, oh, I didn't. That was interesting. I thought that's what it was. Let's try 1,100. It has to be a little bit more, maybe. There it is. There we go. So, okay, 1,100. So that's gone here. So now, yes, Ohio has the 15 here as compared to what it should have, the 15. In the meantime, these 2 numbers here also decreased because I changed my standard divisor to the adjusted divisor. That's why these ratios here actually changed, because everything else changed slightly. But still, New York is closer to 1.00 than Minnesota is. And if I increase this correction term here from 1,100 to an interestingly number 1,827, so actually a pretty accurate number here. There, it's gone. And New York indeed has 26 representative, as in fact it was allocated. Let me reverse that. So we're back here. New York has 27. It ought to be reduced to 26. Minnesota has 8, stays at 8. So when I do that, the correction term, there indeed it is 26, 26, 8, and 8. And again, what it did to the population, to the people per one representative, yeah, New York and Ohio were relatively small compared to the other numbers. Now they're actually relatively large. Notice in this case here, actually Nebraska and New Hampshire are kind of exceptions here to that, because they have very few representatives to begin with. So we have to exclude them here, and that's what the Huntington Hill method is. It's favorable for Nebraska because they have so few to begin with. If we took one away here, then it would actually be like almost 1 million for the remaining 2. So we really cannot do that. So 654,000. Again, the mathematical method takes care of that, which of course then, yes, does increase the population here per representative for New York and Ohio quite a bit to 2 of the largest numbers in here. Okay, last on this particular one here, because is that Minnesota, I pointed out, was so close to New York, the 2 numbers that we used to have here for the ratio, that when I go back, I'm going to put this one here as a 0 again. And these 2 numbers were really close. And when I go back in the news, I found these here, that in the census, like in 2020, Minnesota was happy that 26 people out of the, was it 5 million? Yes, 5,700,000, that they actually had those 26 people extra there because it gave them one more seat. And New York was unhappy because they were 89 people short. So if 90 people had lived more in New York, they would have actually gotten one more seat and wouldn't have lost it, and Minnesota would have lost one. And I can show that too, that 26 here. I'm going to reduce this one here to a 22. So 5,709,722 instead. Okay, there we go. Now notice this number here. Wow, it's virtually the same. Let's reduce a little bit more. Just a little bit. There, now we can see a difference, right? Minnesota. So in this case here, actually, for the computation, if that had been the case, Minnesota having 40 people less, I know they say 26 here, but I want to show the difference. Then if we do the adjustment, I'm going to try the same number here for the adjustment. Okay, that's actually, let's see which one works. Oh, okay, well, very, very small differences here. There it is, 1,824. Now it's actually Minnesota that would have lost a seat, and New York would have actually kept a seat. But that was not the case. Minnesota had those extra 40 or 30 people, or 40 people or 26 people, and that was actually good enough for them. 1,827 is the correction term. That they kept their seat and New York actually lost one. All right, so overall, that is the Huntington Hill method for the apportion